Welcome everyone. It is my absolute insane pleasure to welcome the great Dylan Beattie to our little conference here. I couldn't be happier about his speaker. I've seen him a number of times at conferences. I watched all of his videos. I enjoyed every single one of them. And we're even lucky enough to have him present some new stuff for us today. If you've ever watched Dylan talk before, you know that you're in for a treat. I'm really looking forward to that. And without further ado, I'll hand over to you as usual. There is room for some questions in the chat, and if we have time left at the end, I will try to ask him the most interesting or funniest ones, or I don't know, the ones that I think might bring us the most fun when he tries to answer them. So, Dylan, please go ahead and do your thing. There you go.
Fantastic. Thank you, Stefan. And hello, everyone. Guten Abend to the folks in Germany. Good evening if you're in the UK, and good afternoon if we got any folks over the other side of the Atlantic. And if you're watching from another time zone through the wonders of the internet and online conferences, very happy whatever hour of the day it is to you. And yeah, welcome. My name's Dylan Beattie, and the crew from INNOQ have invited me to join today to talk to you about something called computational creativity. So this is me. I run a company in London called Ursatile that unexpectedly became an online software training company earlier this year, and has been doing all kinds of fun stuff with online workshops about programming and distributed systems, and really kind of exploring what we can do with that format. I'm a Microsoft MVP, and I run a .NET user group here in London. Now, some of you might have heard of something that I did, because you probably heard about this whole idea of rock star programmers, right? And all those LinkedIn adverts and everything. And so a few years ago, I thought it would be fun. Why don't I just make it so everyone can be a rock star programmer by making a programming language called Rockstar? So I did, and that has just been, it's a daft, stupid, joke, esoteric language that's turned into a stupid joke with GitHub issues and a reference implementation, and at the moment we're doing some Advent of Code stuff with Rockstar as well. So that's a lot of fun. And the other place you might have seen me was this talk, which I did at a couple of events end of last year, which has now gone, one of them has kind of gone viral on YouTube and has got, I think, 1.2 million views or something. And, this talk is called The Art of Code, and it pulled together a lot of my own kind of ideas, things that I was interested in about music and technology and esoteric programming languages and art and beauty and all these kinds of different ideas. And, lots of people said, what are you going to do next? And I was like, well, I feel like I haven't finished exploring a lot of those ideas. And a lot of them we can look at from a different perspective, because, some of the ideas around the way technology and artificial intelligence, machine learning, the ways that those interact with human beings as creative individuals, and the social and the kind of legal questions that come up around that. I think there's lots more interesting stuff to discover there. So that's what I'm going to be talking to you about today. Now, I kind of invented this title, Computational Creativity, and then a couple of weeks ago, I was reading this book. Sid Meier's the computer games designer who made Railroad Tycoon and Pirates and all these kinds of games. And halfway through this book, I found this phrase. He uses that exact same phrase, computational creativity. He's talking about they were trying to write a computer system in the 90s that would generate mystery games, murder mysteries that would be different every time, so you could play this detective game over and over again, which is a wonderful idea. But I thought it was a nice bit of serendipity to find this phrase, computational creativity. And it's a great book as well. So go and check it out if you're interested in history of how people write computer games and stuff. And there's this lovely phrase here. It says they're talking about things that were only a little bit impossible, which is not the same as completely impossible. And that's kind of fun, because some of the stuff I'm going to be showing you tonight kind of fits into that. It's stuff that's a little bit impossible until we figured out how to do it. But let's start at the beginning. We're going to go way back in time now. These are some cave paintings in Indonesia. They were discovered last year, and they've used carbon-14 dating to date these. This is 40,000 years old. Archaeologists think this is the oldest art that has ever been found. This is the oldest preserved piece of, humans documenting something by drawing pictures and stuff. And the thing I think is wonderful about it is if you look really closely, this is a hunt. This is like a bunch of these little humanoid figures chasing this animal. But one of the humanoid figures has got a head like a bird, and another one has a tail. And what this says to me is that the second we invented this kind of technology, we invented painting, someone was like, yeah, let's use it to tell stories about things that don't really exist, but they might. Let's make up stories. Let's do fiction. And I love that kind of idea that as soon as technology is invented, humans are like, what cool stuff can we do with it? What can we make up here? What are the possibilities? Now, this marked the start of a long tradition of visual art, sgraffito, painting, sculpture, Michelangelo, Da Vinci, Frida Kahlo, Hokusai, this long, long illustrious tradition, all of these different visual schools and techniques and styles. And in the 1840s, there was a group of French artists founded an art school called the Realists. And they weren't interested in kind of, romanticized notions of, saints and gods and all these kind of things. They wanted to draw reality. They just wanted to paint real people in real scenes doing real things, people farming fields and people getting ill and going to the doctor and all this kind of stuff. And the realism movement was massively influential. But in the second half of the 19th century, something happened. There was a technological innovation that basically wiped out the realism movement overnight. It's photography. Realism was pretty much obsolete. Why would you spend days laboring stroke by stroke over a canvas when you could just point a camera at something and capture it? Get it. Now, the first big revolution was film camera. That replaced realist painting. And then digital photography has almost as revolutionary, the effect that it's had on the way we see and the way we capture the world around us. It used to be you take 24 photographs on holiday and then wait and pay money to get them developed. And now, you can take 24 selfies with your friends in a bar just because you want to see one good one. And we don't just capture the most beautiful and amazing things that happen in the world around us. We take pictures like this and we go out and we stick them on Instagram. So next time you're in a bar with your friends, you get a selfie, just take a moment and spare a thought for the realist French painters who were all put out of jobs when photography came along. And this is a pattern that has played out over and over again. From 1760 until about 1850, 1860, the Industrial Revolution happened. And all of these fields of human endeavor, textiles, agriculture, mining, manufacturing, things that employed hundreds of thousands of people, suddenly they could be automated. And the changes and the effects and the impact of that is still being seen all around us today, Now, some of you may have heard this word Luddite at some point. It's a kind of derogatory term for somebody who just will not get with the program when it comes to technology. The people who are like, oh, why do I have to do my own emails? No, just can you send it? Can you print it out for me? The people who are like, I don't want to use a word processor. Can I have a typewriter? And now suddenly in 2020, the people are like, I don't want to do meetings over Zoom. I want to be able to go and sit in an overheated conference room again. And the whole idea, this word Luddite, comes from a real person, a guy called Ned Ludd, who was he was a weaver. And he was afraid that technology was going to take his job, and he went out one day and he smashed up a bunch of textile weaving looms with a hammer, and he became a folk hero. He inspired a protest movement they called the Luddites, and he also kind of marked the start of this uneasy relationship between humans and progress, right? Because for every innovation that comes along, some people embrace it. They're like, this is new, this is exciting. What can we do with it that we couldn't do before? And other people are fearful. They're like, this is new and this is frightening to me, and this is going to change the way the world works, and maybe it threatens something that I take for granted. And it raises all kinds of questions about things like, innovation and creativity and credit, and how do we solve problems? How do we do work? Who gets the credit? Who's entitled to what? Now, we're going to start off with one of the first really mainstream applications of digital technology and computers. We're going to go back to the 1950s. Here are some computers from the 1950s. Because in the 1950s, computer was a job title. It was a job. Computers were people who were hired by engineering companies, aerospace companies, to do calculations. They sat at a desk with a pen and paper, and they did calculations there. And if you've seen the movie Hidden Figures or read the book, the movie came out in 2016. It's about a team of these computers who were working at NASA in the 1950s. And you probably remember this scene.
The IBM 7090 data processing system. It has the capability of solving over 24,000 multiplications per second.
Holy Moses, that's lightning fast.
They'll never get that to work.
Oh, it'll run eventually. And when it does, we have to know how to program it. Unless you'd rather be out of a job.
No.
The woman, Octavia Spencer, is the actor there. The woman she is playing is Dorothy Vaughan. And Dorothy Vaughan joined NASA as a computer with pens and paper. She worked there till 1971. By the time Dorothy Vaughan left NASA, human beings had walked on the moon. Hewlett-Packard had created the first pocket scientific calculator. Intel had the 4004 microprocessor, which was the predecessor to the whole 86 instruction set that a lot of us still use today. Xerox had built the first commercial laser printers. ARPANET had been invented. People were sending email. And of course, the word computer wasn't a job title anymore. A computer was a thing. It was a machine that did calculations. And all of those, innovations, space travel, pocket calculators, computers, laser printers, the internet, all of them changed the world in a way that we are kind of still coming to grips with a little bit today. But, pocket calculators, arithmetic is not terribly creative. Some equations have a solution, and we don't really care how you get there. You don't get bonus points for doing it in a clever way. You just need the right answer. The faster, the better, especially if you are trying to beat the Russians to the moon in the space race. Now, when I was a kid, and I'm sure for some of you this is the same, I had a pocket calculator that I was not allowed to use in school. And my teachers would be like, you need to do all the sums and learn your arithmetic and your times tables. And I'd be like, why? And they'd be like, well, when you grow up, you won't have a computer in your pocket. And I'm like, well, here I am, 42 years old, and I always have a computer in my pocket. So sorry, Mrs. Marshall, I think I won that one. But, the whole idea of arithmetic, like I said, is not terribly creative. It's not a big deal. Now, when I was a teenager in school, we had computers. I had word processors. I had WordPerfect 5.1 for DOS. And most of my classmates were still writing their homework, with pens and paper. I was using a word processor because I was a nerdy kid who liked gadgets. And I had these arguments with my teachers about whether I was allowed to use a spell checker to do my homework. And the stupid answer, the answer they came up with, so WordPerfect, you go tool spell, and it would just look through it and it'd tell you if the word is in the dictionary or not. Yes or no, true or false. Didn't tell me if I was using the word correctly. It just told me, did I find this word here in my lookup table? And, I'd argue, well, it's just a dictionary. I'm allowed to use a paper dictionary. And my teacher would go, yes, but if you use a paper dictionary, it'll tell you what the word means. And I'd be like, if I don't know what the word means, why am I using it in my essay? And the compromise that we reached was that I was allowed to use a spell checker for geography and history and all these other things, but I wasn't allowed to use it in English because the point of English was to teach me to spell. And so the word processor for English would be cheating. But like I said, word processor spell check, all it can really do, certainly WordPerfect 5.1, it just tell you, is the word in the dictionary? Doesn't tell you whether it's the right word or the right spelling of the right word. And this behavior has been beautifully immortalized in this poem, Ode to a Spell Checker by Gerald Czar. I have a spelling checker. It came with my PC. It plainly marks for my review mistakes I cannot see. I strike a key and type a word and wait for it to say whether I am wrong or right. It shows me straight away. Now, when I wasn't in school writing poems with spell checks and stuff, this was mid-1990s, and I was sneaking into movies I wasn't quite old enough to watch, and the best movie in the 1990s, 1991, was Terminator 2 Judgment Day. And that movie had everything. It had killer robots from the future, and it had massive guns in it, and it had motorcycles, and it had Guns N' Roses, and it had this, the T-1000, a liquid metal shape-shifting robot. There is no sound on this clip, by the way, but you don't need it. Now, when my friends and I were watching this in the cinema for the first time, we were just blown away. We'd never seen it. Nobody had ever seen anything like this. Terminator 2, this effect, they had a $5 million budget for visual effects. And a team of 35 people worked on it for a year. And it won the Academy Award for Best Visual Effects for that, the T-1000 liquid metal effect. But it was not the first time that people had used computers to make a movie. 1982, a guy called Steven Lisberger made this film, Tron. And Tron was a story. Jeff Bridges plays this programmer who gets sucked into a computer and he has to fight his way back out, and it's this wonderful kind of fantasy parable, and it was made using computers, and this was massively controversial. Now, Tron was paid for by Disney. The Disney Corporation funded it, and they distributed it, but none of their animators would work on it. They're like, we're not touching this thing. You are going to destroy our jobs. You are not allowed to use computers to make movies. That's cheating. Now, it isn't that no one had ever kind of made a movie with computers before, but what they wanted to do with Tron was they wanted to use the computer to make scenes and characters and props and film scenes like this one, the light cycle sequence.
Copy, Blue Leader. Copy, Blue Leader. This is Gold 1 to Gold 2 and 3. Split up. Take them one on one. Watch it, watch it.
Now, the amazing thing about that scene, they did not have the technology on Tron to combine live action and computer graphics. So anywhere there's a human being on the screen, all the graphics have been hand-painted by a team of animators working in Taiwan, because Disney wouldn't touch it, obviously. Tron did not win an Academy Award. Tron was banned from the Academy Awards because the Academy said that using computers to do that was kind of cheating. Now, like I said, they'd used computers to make movies before. If you watch Alien, you watch Star Wars, you watch various other films from the 70s, they had computer graphics. But in the movie, they are on a computer screen because the Academy are like, well, that's fine. That's a computer. That's allowed to look like a futuristic computer. Now, the thing about making movies with a computer in the 70s is it was actually much, much easier to fake it. Tron had this incredibly complex production cycle of rendering one frame of video. It took 6 hours. Then they'd expose a single frame on the camera. And then they'd start the next render cycle, which was another 6 hours. Now, there's another movie you probably remember from the 80s. It's John Carpenter's Escape from New York. Take a look at this sequence here. It's the glider sequence. Snake Plissken is gliding into Manhattan to rescue the president who's been kidnapped. And have a look at the guidance computer system you can see here.
Are you picking up the target blip?
That is not a computer graphic. That green screen was filmed on a soundstage. James Cameron, who went on to make Titanic and Alien and things, he got a bunch of cardboard boxes, he painted them black, and he put green piping around it, and then he lit the whole thing with an ultraviolet light and walked through it with a camera. That's how they got the computer graphic. It was easier to cheat than it was to get the computer to do the computer graphics because computers were so expensive. But like I said, for Tron, they got this thing. The Foonly F1 is the only computer in the world capable of doing it at the time. 6 hours per frame. This thing, by the way, is based on, if anyone's heard of the PDP-10, this is like a one-of-a-kind, hotshot, turbocharged PDP-10. Tron eventually, like 14 years later, the Academy went, we're very sorry, you deserve the Special Achievement Award for innovations in visual effects and stuff. But by the time Terminator 2 came along with the liquid metal killer robots from the future, the balance had flipped. And the computers could now, they made hard things easy and impossible things possible. Things that were just a little bit impossible, you could do now. But they raised all these interesting questions about who's actually making the movie. You know, you look at a scene like this one we got here. A computer programmer wrote an algorithm that would allow this liquid metal robot to rise up out of the floor. So who made the scene? Was it the person who dressed the scene? Was it the person who wrote the algorithm? Was it the person who programmed the algorithm? Was it the person who clicked run? Was it the director? Was it, who gets the credit for creating these kinds of scenes? Now, these days, the power of computer-generated imagery in movies is pretty much unlimited. We can create just about anything. If you have a look, this sequence, the Battle of Minas Tirith from Lord of the Rings, The Two Towers, completely computer-generated. Every single pixel you can see on this screen is generated by a computer. But it's not the computer just rendering the scene. In scenes like this, the computer is actually doing the acting as well. Because all of those soldiers on that battlefield, they are being animated by a thing called Massive, the multiple agent simulation system in virtual environments. You can drop 10,000 orcs on a battlefield and just basically shout action, and they will work out where to go and who to hit and what to do. And you as the director just kind of say, right, move the camera over here. And there is a wonderful anecdote. This scene in Return of the King, where the Oliphant war elephants turn up. First time they ran this scene, a bunch of the digital human soldiers in the simulated battlefield turned around and ran away because they were frightened. Now, it actually turned out there was just a bug in the routing code. But, historically, if you're filming a big battlefield scene like this, all those actors would be actors. They'd have a bit of training on how to use weapons. The director would tell them what to do. Suddenly, it's just the director saying, right, put 10,000 orcs over there and make a battle happen. Who gets the credit for that? Who should get the acting royalty? Are there even acting royalties to think about anymore? How does this compare to the way we used to make movies 10, 15 years ago? And this started asking questions, and things just get more and more and more complicated. And a couple of years ago, we got this.
I believe I owe you an apology, Director Krennic. Your work exceeds all expectations.
Now, who is that? Because Lucasfilm's lawyers say that is Grand Moff Tarkin. He's a fictional character who happens to look a little bit like the British actor Peter Cushing, who played Moff Tarkin in Star Wars in 1977. And bringing this character back to life digitally, they did it using an astonishing combination of motion capture, computer graphics, and a performance. The voice and the kind of, body movements and everything are an actor called Guy Henry. And, there was this wonderful little thing on the ABC Nightline about how they put it together. I got a tiny bit of that here.
Underneath digital Tarkin is a real actor, Guy Henry, who carefully studied Cushing on the set.
Lost in the attack.
It's Henry's voice and performance that the ILM artist used as a guide.
The original plans for the station are kept there, are they not?
Charming to the last.
This is the earliest test.
As the first time we ever saw Guy's motion transferred onto Guy's model and then put onto Tarkin's an early likeness.
The problem is Cushing's performance and Henry's performance didn't always match. That required painstaking, sometimes frame-by-frame adjustments, constantly refining the most subtle details you can imagine. The makers of Rogue One had the blessing of Cushing's estate, but the effect is drawing some criticism over the ethics of bringing back well-known actors long after they're gone.
This work was done with great affection and care. Some of the objections I've heard about this is makes references to the Fred Astaire with the Dirt Devil.
Nothing escapes the power of a Dirt Devil.
Or Audrey Hepburn selling chocolate. But that's not what we've done here. I'd like to think that the role that we gave Tarkin in this film is one that Peter Cushing would have been really very excited and happy to play.
Now, it is possible now. Hollywood directors can use CGI to create just about anything they can imagine. And if you sat through Cats or any of the Michael Bay Transformers movies, maybe you're thinking we've gone too far and we have given them too much power. But the next massive paradigm shift that's come along, computer graphics in a Hollywood studio, they've used them to do the Marvel Cinematic Universe, these huge space battles, all the way down to things like digitally removing a tattoo. In the first Wonder Woman movie, Gal Gadot, the actress who plays Wonder Woman, she was actually pregnant when they filmed it. And they made her wear a green screen around her belly so they could make her look not pregnant in post-production stuff. They can do pretty much anything with this. But it's not just Hollywood anymore. It's got to a point now where pretty much anybody with some relatively inexpensive computing hardware can do some scary and, slightly unsettling kind of things.
We're entering an era in which our enemies can make it look like anyone is saying anything at any point in time, even if they would never say those things. So, for instance, they could have me say things like, I don't know, Killmonger was right. Now, you see, I would never say these things, at least not in a public address, but someone else would. Someone like Jordan Peele. This is a dangerous time. Moving forward, we need to be more vigilant with what we trust from the internet.
More vigilant with what we trust from the internet. How do we know what to trust? The media sources we rely on, the footage we see. There was a day when, hey, if you had a photograph of something, it definitely happened. That stopped being true 30 years ago. Then it was like, well, if we've got video of it, then it definitely happened. That probably stopped being true 10 years ago. You know, where is the end game for all this? And how do you determine who and what you can trust? Now, this has big implications for online publishing and all kinds of things. There is a set of laws in the UK and most of Europe, in fact, most of the world now, has laws about what we call libel and slander. You cannot publish something that is defamatory or damaging or insulting to somebody. If a newspaper ran a front page story that said I was having a secret affair with Jar Jar Binks out of Star Wars, I could sue them. I could say, you made a conscious act to print something that is not true. You cannot verify it. You owe me damages. If that is a website, if you want to go on Facebook or Twitter or Instagram and say, hey, I saw Dylan kissing Jar Jar in a cocktail bar, there is nothing we can do about it because those platforms are not publishers. They have been legally deemed to be neutral platforms that just allow people to talk to each other, and they have no publishing discretion. They have no agency in that. Now, for a while in the 1990s, it looked like websites and internet providers could be held legally liable for anything that happened on them. You know, imagine if everybody who didn't like a Facebook post could sue Mark Zuckerberg personally and say, I didn't like what was on your website, I'm going to sue you for $1 million billion. He'd be in court all the time. That's the only thing that ever... Social media would be impossible. It literally would not exist as we know it. Now, the section of the United States Communications Act that allows this to happen is called Section 230. It's been in the press a little bit recently because certain individuals don't like what Twitter has been saying about what really happened in the election. It says, no provider or user of an interactive computer service shall be treated as the publisher or speaker of any information provided by another information content provider. The courts have accepted it. Websites are neutral. You post something on there, other people can read it. The website did not publish that. They cannot be held legally liable for it. And it worked. You know, social media worked. Facebook was invented and became successful and has like 4 billion users now. Twitter, Instagram, Reddit, all of these platforms couldn't exist without the protection of Section 230. But it's raised a whole bunch of other complicated questions around it. If you go on Twitter, there is a thing called top tweets, which keeps switching itself back on. And top tweets is the thing that says Twitter, or Twitter's algorithms, they are going to decide what they think you should see. So if I open a Twitter feed and it shows me the moon landings were fake, coronavirus is a hoax, and Joe Biden is a lizard person, whose opinion are they pushing there? You know, because it's not a conscious decision, but it's also, that's not a balanced representation of the information that's available on that platform. Who's liable for it? If it's pushing misinformation that furthers a particular agenda, can anybody be held accountable for what's going on there? And they can't. There is no human being who did that. You can sue. We can't take algorithms to court because we haven't even begun to think about the legal framework that does that. But all of these platforms now, you know, YouTube, Instagram, Facebook, Flickr, Twitter, they are relying on algorithms to curate content. They are relying on algorithms to say, hey, you should look at this next because they want your attention. They want your focus. They want you watching their platform. And the recommendation, you know, you go on YouTube, watch a video, it'll recommend another video. And you watch that, it'll recommend another video. It is never, ever going to recommend, hey, that's enough YouTube for today. Thank you. Go outside, call your mother, drink some water. Because the algorithms have been trained on data sets that say the longer you watch, the better you are. Good algorithm, have a biscuit. The perfect YouTube user, by the model that is used to train their algorithms, is someone who sits down one day, they open their laptop, and they never go outside ever again. That is full marks 100% for the recommendation algorithm. Now, it's not that they're all evil, they're just recommending stuff based on what you did. And I've found some fantastic stuff through recommendations. I listen to Spotify a lot. And Spotify gives me these shuffles, which are music I love, music I forgot I loved, and music that I love once I listened to it. And you ever notice how, if you're having a good day and you'd kind of put Spotify on and you just let it do its thing, it keeps recommending songs. You're like, actually, yeah, I forgot. This is really cool. And next thing you're dancing around the kitchen and you're playing air guitar and you're singing and stuff. And there's a channel on YouTube that I found through the algorithm. It's just called My Mechanics. It's this guy who restores machine tools and old bits of hardware. And it's beautiful. There's no music. There's no dialogue. It's just him in his workshop. You never see his face, just doing awesome things with machinery. And, some of these algorithms are fantastic. Some of them are frightening. All of them would have been a little bit impossible 10 years ago and definitely impossible 100 years ago. But as anybody who works in IT knows, the algorithm is kind of only half the solution. The other thing is, where is the algorithm running? What is the platform that is going to turn your code into reality? And platforms are not perfect. Let's talk about Knight Capital. In mid-2012, Knight Capital was the largest equities trader on the New York Stock Exchange. They had $289 million of trades in 3 months. They represented about 17% of all the equities trading going on in the US, on New York Stock Exchange and on NASDAQ. And they did this because they had software. They had SMARS, which was a automated software for routing stock exchange trades. Now, in 2012, the New York Stock Exchange rolled out a set of rules, something called the Retail Liquidity Program. Details aren't important. It required a software update. All the people who had computers connected to the New York Stock Exchange had to build and release an update to be compatible with this new software. And August the 1st was the day that Knight Capital released their upgrade onto the 8 servers in their trading platform. Except they didn't. They only released it onto 7 of them because the engineer who did it missed one. And it turned out that inside the SMARS platform, there was an old feature, there's a thing called PowerPeg. And PowerPeg's job was you took a massive order for $100 million worth of securities, and it would break it down into little orders, and it would submit those orders to the stock exchange until it had filled its quota, and then it would go, right, done. Now, they'd stopped using this 9 years ago. They'd taken the safety off. That thing that registers when the transactions reach the limit, that had been removed. The code was still there, and the thing that activated it was a configuration flag that they had decided to reuse for the new retail liquidity program. So they roll this out onto 7 servers. The 8th server suddenly starts issuing trades, real trades. Imagine an infinite loop that spends real money. First thing they do is they roll back the release, but they don't reset the configuration flag. Now you have 8 servers running an infinite loop that is spending real money. It took them 45 minutes to figure out and shut down, figure out what had happened and shut the whole thing down. The SEC, the Stock Exchange Commission report into the incident, described it as they had inadvertently accumulated an unintended multi-billion-dollar portfolio of securities in approximately 45 minutes. This was a complete car crash of a thing. They lost $460 million. They had to go out and try and buy back all these things they'd sold and sell all the things they'd accidentally bought. They lost $460 million in trading. They also had to pay a fine of $12 million, which must have really stung after they'd lost, $500 million. It turns out that letting computers in infinite loops buy securities isn't just a bad idea. It's also massively illegal, and it breaks all kinds of regulations. But, whose fault was this? Who would you blame? The engineer who missed one server? You ever got to roll something onto 8 servers and you miss one of them? Do you think that is a $500 million mistake? The meeting where someone said, well, we're out of configuration flags, but there's this one we can reuse. It's for a 9-year-old feature we're not using. Is that a $500 million mistake? When developers write algorithms that make $1 billion on the stock market, those developers don't normally get the $1 billion for themselves. And I think it's important that that goes in both ways. When we give people tools they use to get rich, we maybe get a little bit rich, but we don't get all of it. But if we give people tools that they use to go bankrupt, we shouldn't go bankrupt as a consequence because the chain of cause and effect is too complex. Knight Capital was pretty much wiped out. Went down in history as a good example to use in talks like this in undergraduate lectures. Lost 75% of their equity. They were acquired by a rival a couple of months later. But, even then, Knight Capital's system, you could still trace what happened. It just happened really, really fast. Everything their system did was stuff that human beings used to do. It's just they were now doing it millions of times a second or millions of times a minute, Where it gets really kind of murky and complicated is we have to start thinking about a new kind of automation where we can't break it down into logical steps anymore. We train machine learning models and neural networks, and then we're like, is it good? Does it work? I don't know. Let's find out. Recruitment. It's one of the biggest challenges in IT. I'm sure anyone who's ever looked for a job or tried to hire people knows that it's a massive headache. Matching the right people with the right jobs, huge amount of time and effort and energy. And there's two things. That's one of the truths about IT is recruitment's really hard. And the second thing that's true about IT is if you give us a problem, we're going to try and automate it, right? And Amazon tried to automate hiring. In 2014, they had this brilliant idea. We're going to take every single resume, every single CV of everybody who has ever applied to work at Amazon. And we are going to go, right, here's 10 billion CVs or however many they got. We hired these people. We didn't hire those people. Let's analyze them and find the patterns. What makes the ideal Amazon employee? Who are the kind of people we hire? They ran something like 500 different computer learning models over this thing, looking for the patterns, And they found patterns. But the patterns they found were not really patterns that they wanted to find. They discovered things like any resume with the words women's chess club on it was getting downgraded. Those people were probably not getting hired. Anybody who had been to colleges that only admitted women, those people were not getting hired. There were all these keywords and consistent patterns in people who had been turned down for jobs at Amazon. The people who were hired, there was no pattern. They were completely random. Amazon was filtering out the people they didn't like. Now, what this machine learning thing did is it modeled and it captured and it replicated the way Amazon as an organization was hiring people. It unwittingly unearthed the systemic bias in their entire hiring process by going, this is what you've actually been doing for the last 10 years. Now, Amazon are like, we shut the project down. They say they never actually used it. It was a research project that turned out not to be fit for purpose. And they did go and review a whole bunch of their, recruitment processes based on what they'd learned from this thing. But the algorithm worked because it found the patterns in the historical data. It's just the patterns they found weren't the patterns that they wanted to find there. And this is still going on all over the place. A couple of months ago, thing happened that you might have seen on Twitter. There are suddenly all these little photos popping up of the same white guy side by side twice. And then when you look at one of the pictures, you notice that actually they're different photographs. And Twitter has an algorithm that is going, center this on someone's face. And in this example, we gave it Brad and Jennifer, and in both pictures, it's like Brad is more facey. Brad is a better match for our algorithm than Jennifer Aniston is. Now, I ran a whole bunch of examples through this because I wanted to see what it really did. And the most interesting one that came out of my own research is Twitter's algorithm thinks that Bender from Futurama is a better human face than the Prime Minister of New Zealand. Now, there is a massive amount of systemic bias going on here. But if you think about it, the kind of machine learning models that are used to do this, hey, identify the faces in this picture, that's a model that's been trained on lots of photographs. And the data sets that are used to train it are normally data sets of famous people that are available in the public domain. And because of the way the kind of society that overlaps with software development tends to work, most of the famous people are male and Caucasian. White guys. So you train your database on 10 million white guys and it learns to recognize them all. Then you try it out on the people in your team who are probably also white guys and it recognizes them all. And then you put it out on the internet and this kind of stuff happening and you're thinking, I didn't mean to, what? Did I write a racist algorithm by mistake? Did I write a sexist algorithm? I didn't mean to do that. What happened? I'm not a bad person. Am I? Now, if you take the 8 billion humans on this planet and, gender and race and ethnicity, these are kind of very fuzzy concepts. But if you round up all the humans, go, right, anyone who's like, yeah, I'm a white guy, you come and stand over here, that'll be about this many people. Something about 8-9% of all the people on this planet. Now, just think about it from a purely engineering perspective. If you have a face recognition algorithm that is 98% accurate on your data set, but your data set is only representative of 8% of the human beings on the planet, you've just built an algorithm that's only 4% accurate. Are you proud of that? Is this the kind of success, the levels that we are aspiring to with what we do? No, I want to do better. I want everyone to do better. And how can we fix this? What can we do about it? Well, it's software. Every problem can be solved with another intermediate layer of abstraction in it. First thing we got to do is better data. When we're building these algorithms and training them, we got to look at the data sets. We got to be like, is this fair? Is there bias? Where did this data come from? Who collected it? Did they have some underlying systemic bias that they didn't realize was coming into play here? Better teams. You train the thing on the data, then you want to try it out on the people you're working with, and that's where you want the opinions coming in from people going, I think you might have missed something here. And then we can build a better world. And, well, how difficult can it be changing the world? Well, we've done it. Lots of times. We've changed the world dozens of times since the stuff I talked about at the beginning of this talk. We invented writing, language, electronics, radio, transistors, the internet, Wi-Fi, mobile apps, streaming video. This year we're like, we need to do conferences over the internet. And boom, 8 months later, here I am talking to all of you from my bedroom over fiber optic broadband, The amount of tech involved in what we are doing right this second is staggering, but it works. We did it. It looked really difficult, and we figured it out, and we made a way to make it happen. All we need to do is choose the right problems and point the right people in the right direction. And, think about the way technology has revolutionized things like information about healthcare. It's an increased life expectancy for people all over the world. There's all these questions, all this information that we can get now. How do you set a broken bone? How do you repair a tractor? When's the best time to plant a particular kind of crop? This stuff is there. It's online. It's free. It's in hundreds of languages. You can get it with a smartphone or, $100 laptop, and anyone can get it. Even kids can get online and they can look this stuff up. And that to me is really, really important because, when I was a kid, I had questions about who would win in a fight between Optimus Prime and Darth Vader. My questions were not important questions, but the only place I had to look them up, I could ask my parents, I could ask my teachers, and I could ask the district library in Harare where I went to school, and none of them knew the answer. And if I'd had more complicated questions about, health and sexuality and gender identity, I wouldn't have had anybody to ask. And now you can go on Google and you can type it in and you get answers back and they say, it's fine, it's normal. That's not normal. Get a doctor to look at that. You're okay. Here's people you can talk to. I think that's brilliant. And even if it's going to take us another couple of decades to work out what to do about biases in machine learning and the Russian botnet troll farms and all this kind of stuff, it's worth it. I want us to keep working on this stuff because, think about how much we've accomplished. We've wired the planet. We've blanketed the sky with satellites. There's a lovely expression, we've trapped lightning inside rocks until they learn how to think. And along the way, we've learned some amazing things about ourselves and about the universe that we live in. Now, we've talked over the last hour about a whole bunch of different models of computation, number crunching, calculation, machine learning, computer rendering, algorithmic trading, and somewhere in the background, there's always this big question. What kind of computers are we? What kind of computational model does the human brain use? Will we ever be able to create an artificial one? And there's this lovely quote from Edgar Dijkstra. He said, the question of whether a computer can think is no more interesting than the question of whether a submarine can swim. Now, I want to unpack that a little because a computer can think. We use this word think as a shorthand for all kinds of stuff. I think, how much is 127 plus 255? I think it's 382. How do I get to the library? I think you go down here, you go left. I think Jimi Hendrix is massively overrated. I think I want a pizza. I think I love you. These are not the same process, but anything the brain does, we say that's thinking because thinking is what brains do. But what if we can start breaking it down? What if we start looking at individual facets of human consciousness and see whether that can lend us some insight into how those processes are modeled? Now, one of the oldest things where humans and computers are kind of, faced off against one another is chess, playing a game of chess, one of the oldest games we ever have. Now, the oldest chess program is actually older than computers. Alan Turing wrote a chess program on paper in 1948 that they didn't invent machines that could run it for another 20 or 30 years. Eventually they did, and they discovered, you could play a game of chess. And there's a notebook somewhere of Turing executing his algorithm with just writing out individual lines with a pencil to see what kind of game of chess that it played. Now, by the 1980s, humans played computer chess all the time. There were computer chess tournaments. 1989, Garry Kasparov was the world champion. He took on an IBM computer called Deep Thought. 5 years, he won, by the way. Kasparov won, but then 7 years later, in 1996, the computers won. Deep Blue beat Garry Kasparov, who was the best human chess player in the world at the time. And since then, it's just been a whitewash. The computers are all over everything. Magnus Carlsen, who's the current world chess champion, he says, I don't play computers anymore because they just win all the time. It's not even any fun. But after he lost to Deep Blue, Kasparov did something interesting. He asked the question, what happens if we take a chess player and a computer and we put them on the same side? What happens if the human being, with all the creativity and the psychology and the knowing how to freak out their opponent with aggressive playing or counterintuitive moves, what if we let them use the computer to say, no, don't do that. It's stupid. You're gonna get checkmated in 6 moves time. What if we allow them to join together? Now he called this, I think he called it advanced chess. Some people call it cyborg chess. Some people call it centaur chess. Human plus computer playing against human plus computer. And the astonishing thing here is a reasonably good human chess player with a reasonably good computer is better than any supercomputer or any chess grandmaster. Now think about that for a second. A human being, reasonable club player running, software on a MacBook laptop is a better chess player than the best things the machines have come up with on their own and the best thing the humans can come up with on their own. Now, I think that's fascinating. This idea of it's not that humans are better, it's not machines are better. It's that if we combine them in interesting ways, and Kasparov has said in interviews, he thinks the determining factor here is how good the interface is. How quickly can that human get their moves into the computer and understand what's coming back to it? The interface between the human being and the machine is the key. And that brings us onto the home stretch of today, because I want to take that idea about hybrid creativity, combining human creativity and machines and machine learning in interesting ways to do interesting things. And the thing I'm interested in is music. I love making music when I'm not playing around with computers and stuff. Now, I'd like to introduce you to this guy. This is Michal Lusak. And Michal does all kinds of cool stuff with machine learning and ML.NET. And last year, we were at a conference together in Poland, and he did this talk, Writing Metal Riffs with Machine Learning and .NET. He took TensorFlow and ML.NET models, and he downloaded all of the guitar music for all of Metallica's albums. And he fed all that music into this neural network model and basically told it, write a Metallica song. And this is the last little bit of his talk from that conference last year.
With all those 200 epochs. And then I started generating a sequence starting from random number, and I got this out of it. What I did, I manually transcribed it back to Guitar Pro, and we got this.
I was sat in the audience when he did that, and I thought, that sounds cool. I want to do something with that. And then when I started playing around with the idea, I'm like, right, let's make a Metallica song that was written entirely by computers. And I emailed Michael and I said, hey, how's that thing going? And he sent me the files for that. So we had some music. But songs need music and they need lyrics. So I started thinking, how can we get a machine to write Metallica lyrics? Now, the gold standard for computer-generated writing at the moment is a thing called GPT-3. And a little while ago, GPT-3 wrote an article that was published in the Guardian newspaper. They sent it a brief, just the way they would, hey, give us 500 words on what it's like to be an artificial intelligence, and it sent back this. And the editors kind of cleaned it up a little bit and ran it in the newspaper, and it is attributed to GPT-3. The algorithm wrote this. Now, GPT-3 is in private beta, and I keep trying to get in, and I think the problem is I keep telling them that I want it so I can use it to make Metallica songs, and maybe they're just being like, this is serious research, you're not supposed to be using it for heavy metal. But there are other ways that you can use machines to generate words and writing and lyrics. And the model that I decided to use for the last bit of this is something called a Markov chain that you might have heard of. Now, the way Markov chains work is you feed them a bunch of input, and they look for patterns. You take a word, and you're like, all right, what word might come after this one? So I just want to demonstrate. Let's imagine we took a very small Markov chain, and we trained it on the lyrics to Hotel California by Eagles. So we got this whole set of lyrics. We feed all those in, and then we're like, right, start with the word she, and it goes and looks at the song, and it's like, well, the word she is always followed by stood or lit or showed or got. Pick one at random. She showed, right. Showed. What is the next word after showed? Well, at this point in Hotel California, she showed me the way. That's all we got. Me. showed me what? Well, showed me the way, bring me my wine, let's go with my. And then what can follow my in the corpus of Hotel California? My hair, my sight, my wine. Pick one at random. There we go. She showed me my hair. Eagles Hotel California lyric written by a Markov chain. Now, that's a very small chain because I only trained it on one song, and we just got one line out of it. There is a website called lyrics.rip, which has populated Markov chains with all the lyrics to all the bands you can think of. And there's a couple of people on YouTube who have taken these lyrics and they've written their own music and stuff for it. And what I wanted to do was to get lyrics.rip to create some Metallica lyrics to combine with Michael's TensorFlow Metallica riff. So I went on there and I punched in Metallica and I got a bunch of lyrics out of it. And yeah, curated them a little bit and kind of picked bits that I thought worked well. And I'd like to close today by sharing with you, and this will be pre-recorded, I'm afraid, because of the limitations of the Zoom technology, but I'd like to welcome some special guest clones of me to round out this talk. This is Heavy Skies, written by TensorFlow and Markov chains. And on that note, INNOQ, thank you very much to my musical collaborators, Michael, all the lyrics ever written. Now, every word of that song was actually written by Metallica. I just got a computer to put them in a different order. So you work out later who actually wrote the lyrics to that song, because I don't know, but it was a lot of fun playing around with it. Thank you very much, INNOQ. It's been a lot of fun talking with you. I think we have about, 8 minutes for questions? And I thought there's something called a fireside chat on the program there as well. So if you have questions, sling them in the chat, and Stefan is gonna relay them on to me. How you doing, Stefan?
I'm superbly entertained. I enjoyed it so much. I can tell you, so great. Thank you so much for.
It's always hard to read the room when it's in a different continent.
It was a little bit unrealistic because I think the drumming was too good for Metallica, but other than that, I loved it. So, perfect. Thank you so much for this. So I think we had a bunch of comments. I think everybody was entertained. I saw people even, messing up the chat here in the Zoom call, which was supposed to be used only for emergencies. So people just use it because they were so thrilled by it.
I did see it. Awesome. Unfortunately, they did it in German.
I have some comments.
Love, Death and Robots finde ich ja auch eine spannende Entwicklung in die Richtung, which I have no idea what that means.
We could continue this in German if you want to.
I can read it, but I can't speak it.
That's okay. So, that was great. I have a number of comments more than questions.
Yeah, go for it.
Which I think were interesting. So one was that, of course, Darth Vader would win.
Well, yeah, because he has the Force.
Yes, I mean. That's
but if Optimus
obvious.
Prime transformed into a truck, how would Darth Vader know which truck to use the Force on?
Yeah, I like that one.
Yeah.
Another comment I found interesting was that, in theory, that video. The deepfake technology, the video stuff, in combination with a video conferencing tool like this one would be an awesome video compression algorithm, wouldn't it?
That's been done. NVIDIA have released a prototype of a video conferencing system that instead of taking video footage, it does a machine analysis of the kind of key motion capture points on your face, and it sends those, and then it kind of rehydrates a digital face at the other end. And it's uncanny, and it uses something like 0.5% of the balance. Like if you have a powerful enough graphics processor on either end, you can do real-time video calling basically over dial-up, because the amount of data required is so small. So yeah, that's an active research project, and I think we're going to start seeing results from that probably within I don't know, it's kind of, there's all this innovation happening at the moment while the pandemic is still going on, and I wonder, they just started today or yesterday rolling out the first wave of vaccines here in the UK, and if like in 6 months' time the vaccine is kind of commonplace, are people going to keep investing this heavily in video conference technology, or are they just going to be like, yeah, it's all right, we can go back to work now. Everyone, give back your modems. I'm really interested to see how much of the sort of innovation and the adaptations that we've made to cope with 2020, how many of them are going to be permanent, and how much of it is people just going to go, no, it's finished, we're going back to doing things the old way now. Anyway, yeah.
It sort of raises the question, where does it start to become really creepy, right? I mean, if it's just you, your current, self being optimized this way, it's kind of a better compression algorithm.
Yeah.
If it's the way you looked like 3 years ago or 10 years ago, when you were a little bit younger or whatever, had more hair or a different color, maybe that's still okay. But if it's not you at all, but somebody else you'd like to be, then I don't know. Where exactly would you draw the line? So.
Well, it does. It highlights very interesting questions, something I touched on in the talk about how do you decide who to trust? And, we live in a day where it's like, all right, let's say that there's a broadcaster, I don't know, Walter Cronkite, the guy who was the kind of anchor person for the moon landings and stuff. Very famous, very respected US journalist. And, if you went back in time with some deep fake technology and you put Walter Cronkite on the evening news, people would believe it without even questioning it, Whereas now, I think we're getting to a point, you see video of something, you stop and you think, is that real? At least, but then it's like, well, if anything could be fake, how do you know who to trust? Actually, it reminds me of a lovely quote from the book Crypto by Stephen Levy, where he's talking about Whit Diffie and Marty Hellman. He says Whit Diffie's problem was he met a woman, he fell in love, and he's never trusted anybody. And he's like, in a world where you can't trust anybody, how do you engage with the one person you've decided you want to trust? And that was kind of informed a lot of Diffie's work around what became Diffie-Hellman cryptography. But I've always loved that quote, in a world where you can't trust anyone, what do you do when you decide to trust someone?
Yeah.
And I think that has interesting implications for, broadcast media and social media and all kinds of things. And, just even, going down to a bar or something, talking to some friends and being like, well, that must be real because, you can smell them. And I don't know where it ends, but I find the questions fascinating.
Another very important question from the chat is, how's your cat? I bet you get that a lot.
I do. I might be able to see if he is around somewhere. I tend to have the door closed. There are 2 cats here at the moment, although they're actually my girlfriend's cats, but they're staying with me at the moment. They are well. They have been in fine form, and they have been bouncing around and chasing things and wrestling each other. So yes, whoever asked that, the cats are fine. Thank you for asking.
They're co-stars in some of your videos, right? So that's
they've turned up from time to time. Oh, here we go. Lionel is incoming.
Perfect.
Here we go. Hello, mate. There we go. Okay. Conference cat.
Hi, Lionel. Conference cat. Okay, so Dylan, I think most of the rest is just applause and enthusiasm about the keynote. Thank you so much for doing this. It was great to have you with us.
Thank you very much. That was a lot of fun.
We will be available in the fireside chat for a few minutes. So anybody who wants to chat with you is welcome to do that. Thanks again for being with us, and enjoy the rest of your day.
Thank you for having me. See you all around.
Bye.